Good morning, students. Good morning, students. In the last class, we have started with a second combination circuit, which we call it as multiplexer, right? So, and we have seen how to draw the logic diagram, how to write the truth table, and what do you mean by the basic operation of multiplexer, right? So, in today's class, we will discuss the different types of a multiplexer, right? So, like decoder, we have two different kinds of multiplexers. One is 4:1 multiplexer, 4:1 mux, right, and 8:1 mux, right? So what is the corresponding these two muxes are available in the form of ICs, right? So 74153 is a 4:1 mux which has dual 4:1 muxes. There are like 74139 has dual 2:4 decoders. Similar to that, 74153 has dual 4:1 mux, and 8:1 mux IC number is 74151, which has only one. It has a single. It has a single 8:1 mux, right? Next, let us see the symbolic form of 4:1 mux and 8:1 mux, right? So here there are there are two 4:1 muxes, right? So 74153, this IC number is 74153, and it has dual 4:1 muxes, right? So 4:1 mux, we have total 4 select lines, 4 data lines. Let us number them as A0, A1, A2, A3, right? So these are the 4 data lines of first mux, and we have enable active low enable. Okay, similarly this is one dual, this is one 4:1 mux, and this is second 4:1 mux, where the data lines are, these are active high, B0, B1, B2 and B3, right? So these are the 4 data lines of second 4:1 mux, and the select lines are common here. Please note that select lines for both the muxes are common, and outputs are different. This is F1, this is F2. F1 is output of first 4:1 mux, F2 is output of second 4:1 mux, right? Select lines are common, and even enable lines are input. Active low enable lines, they are different. Okay, okay. Next, the symbolic form for symbolic form of 8:1 mux, which is 74151 IC, right? So how many data lines we require for 8:1 mux? Total 8 data lines. 3, 4, 5, 6, 7, 8. That is they are numbered as D0, D1, D2, D3, D4, D5, D6 and D7, right? So, and it also has one enable pin, which is again active low, right? And how many select lines we require? We require total 3 select lines. Okay, so 8 data lines it has, 3 select lines it has, and 1 output line. It has 2 output lines. One is active high, one is active low, right? So when as per the design, you are going to use these outputs, right? So how we are going to use this output, that we will see later once we start designing the boolean functions using these multiplexers, right? So these are the symbolic form of 2 different kinds of multiplexers, right? So next we will see some of the boolean functions, how to design those boolean functions using these multiplexers. So now we will solve some boolean functions examples using the multiplexers. Okay, let me so let us take the first example. Implement Let us take the first example, that is the following function implement the following function using using 8 to 1 mux, right? So 8 is to 1 mux, you have to use 74151. Sometimes they'll give IC number, right? And sometimes they'll give the which mux you have to use, right? So from the IC number, right? So inside bracket I'll write 74151, which is 8 is to 1 mux, right? Sometimes they'll not mention which kind of mux you have to use, it is left to you. And sometimes they'll write only IC number. From that IC number you have to identify that which mux you have to use, either 8 is to 1 mux or 4 is to 1 muxes, right? The given function is f of abc is equal to summation of 0 4 5 6, right? So when it is asked using 8 is to 1 mux, it is very simple, right? So let us say how to implement this using 8 is to 1 mux, right? So enable is active low, I have to make it ground, I have to connect that enable pin to ground, then only I can enable this 74151 8 is to 1 mux, right? Let us draw the data lines D0, D1, D2, D3, D4, D5, D6 and D7, right? And it has two outputs, one is active low, one is active high. So which output will use? We'll use active low output, sorry, active high output, because we are in the given function there's a summation, that means the given terms are min terms, 0 4 5 6 are the min terms, right? So when the min terms are given, the output is high for these four combinations, 0 4 5 and 6. For that I will make use of the active high output, right? Since taking 8 is to 1 mux and designing a function when there are three inputs are given, then it is very easy. Let me solve this problem first and I'll explain you. See, this 8 is to 1 mux has how many select lines? 3 select lines, right? So one is S2, one is S1, one is S0, where S0 is LSB and S2 is MSB, right? So S2 is MSB and S0 is LSB. Similar to the decoder, we need to connect MSB to MSB. So in the given function, in the given input variables, small a is MSB and small c is LSB. I need to connect MSB to MSB. That means S2 needs to be connected to, or A is connected to S2 and C is connected to S0, which is LSB, and the remaining input, that is B, that has to be connected to S1, right? So in this manner you have to connect the inputs to select lines, right? So here we are not going to connect these inputs to data lines, right? So data line, when the inputs are when inputs are connected to data line, that we will see later. First we will see very simple example using 8 is to 1 mux, and the inputs are going to be connected directly to select lines. So when the select lines are 3 and inputs are also 3, then we are directly going to connect those inputs to these select lines. Let us say if I am going to implement the same function using 4 is to 1 mux, in that case 4 is to 1 mux has only 2 select lines, right? So among these 3, only 2 inputs are connected to select lines and the other input will go to data line, right? So that we will see later. First we will try to implement a simple function using 8 is to 1 mux. See now, 0, that means D0 is selected when decoder, when input is 0 0, output D0 is selected, like that. When select line is 0 0 0, when select lines are 0 0 0, because there are 3 inputs A, B, C. So with these 3 inputs, how many combinations I can write? Sorry, 8 combinations, right? So these are the 8 input combinations. This is 0, this is 1 2 3 4, next 5 1 0 1 6 1 1 0 7 1 1 1, right? So when select line is 0 0 0, it is going to select, mux is going to select data line D0, and whatever data I am going to keep here, so that will appear on uh, F, that will appear on the input, sorry, output, right? So here these are the min terms, right? So 0, 4, 5, 6, that means D0, D4, D5, D6, right? So for these data lines I need to connect what? 1. I need to connect 1. Data has to be kept on these data lines is equal to 1, because whenever select lines are 0 and 4 and 5 and 6, for these 4 select line combinations output should be equal to 1. Then when output will be equal to 1? When D0, D4, D5 and D6 are connected to 1, right? So you connect this to 1. The data kept on these 4 data lines are 1, 1, this is D4, then D5 and D6. 1 means you are going to connect it to VCC, or analog voltage is 5 volt, right? So for remaining data lines D1, D2, D3 and D7, these are all connected to ground, that means 0 volt, right? So whenever if I write truth table, right, so A, B, C are the select lines and output is F, right? So you just compare it with the truth table of 4:1 mux. So instead of 4 combinations, here I have total 8 combinations, because there are 3 select lines, right? So F is equal to, when 0, 0, 0 is selected, when select line is 0, 0, 0, it will select D0, right? So D0 is connected to 1. The data kept on this data line is 1. So F is equal to 1, right? So do you have 0 in the given function? Yes. For 0, am I getting 1? Yes, because D0 is connected to VCC. So F is equal to 1, right? Next, 0, 0, 1. 0, 0, 1, if I make select line is equal to 0, 0, 1, so which data line is selected? D1. D1 is selected and D1 is connected to ground. D1 is connected to ground. Ground means it is equal to 0. The data kept on this data line D1, D2, D3 and D7 are is 0, right? So F will become equal to 0. So do we have 1 in the given function? No, I don't have 1 here. So for 1, 2, 3 and 7, I should get F is equal to 0, correct? Are you understanding? Yes. Next, 0, 1, 0, third combination. 0, 1, 0, it will select D2 and D2 is also connected to ground, so F will be equal to 0. Do we have 2 in the given function? No, so output should be equal to 0. Similar to this, continuing with the same procedure, 3 I don't have, so but D3 is connected to ground, so F is equal to 0. 4 is connected to VCC, I'll get 1. 5 is connected to VCC, well, output will be equal to 1, and 6 will be equal to D6 will be is connected to 1, so F is equal to 1 for 1, 1, 0 select line. For the last select line, since D7 is selected and it is connected to 0, F will be equal to 0, right? So this is the truth table for the given design. Okay, I hope you understood this problem, right? So we'll move to the next slide and we'll try to implement one more simplest boolean function, okay, again using same 74151 multiplexer. Implement f of wxy. Wxy is equal to summation of 0, 1, 2, 4, 5, 6 using, now I'll not give which mux it is, but I'll give the IC number, right? So from this IC number you have to identify which mux I have to use, right? So again draw a symbolic form of multiplexer. First you connect the enable pin, which is active low, that has to be grounded to select this 74151, right? Sorry, inputs are data lines are active high, D0, D1, D2, D3, D4, D5, D6 and D7, right? And there are two outputs again, F which is active high and G is active low, right? Now, summation again, the given terms are min terms. That means for these 6 combinations, output should be equal to 1. And it is very easy when select lines. First, connect select lines. These are the inputs. These are also the inputs. Right, so these are the select lines s0, s2, s1 and s0. S2 is msb, and in the given function which is msb, the first input variable itself is msb until and unless it is told. So w is connected to s2, x is connected to s1, y is connected to s0. Right, so when input select lines are 0 0 0, d0 is selected, and do we have 0 in the given function? Yes, so 0 d0 needs to be connected to VCC, which is equal to 5 volt, and it is digitally we represent it as 1. Next, D1 is also there, so connect it to check the given function. Right, so which all numbers you have, which all digits you have, you take that particular data line and you connect it to VCC accordingly. If that particular data line subscript is there in the given function. Right, so I have 2. Right, so do you have a d2? Do you have 2 in the given function? Yes, that means d2 has to be connected to VCC. Do we have 3? There is no 3. Right, so d3 needs to be grounded. Next, d4, yes I have, needs to be connected to VCC. d5, yes I have. d6 I have. Right, next d7 I don't have, so connected to ground. Is it simple? Yes. Right, so if you want to truth table, you write for your reference. I'll not write again and again. Okay, so this is very simple when there are 3 inputs and the 3 select lines using 8:1 mux. Right, so we'll take some more examples on 74153, which is 4:1 mux. Okay, so next example is implement f of a b. Right, so I have only 2 inputs, summation of 0 3, using, sometimes they'll not give, using just they'll say mux. Right, so in this case which mux you will use? You will use 4:1 mux, which is 74153. Because how do you identify which mux you have to use? Look at the number of inputs. If there are if there are 3 inputs, then you can directly use 74151, which is 8:1 mux. And when there are 2 inputs, then you can connect these 2 inputs to 2 select lines. So in that case you can use 4:1 mux, which is 74153. Right, so here only one function is given, so I'll make use of only one 4:1 mux, which is available in 74153. Right, so this here I am using only one 4:1 mux in 74153. Right, so we'll connect inputs, that is data lines, sorry, d0, d1, d2 and d3, and there are 2 select lines, s1 and s0. Right, so here s1 is msb, s0 is lsb, and in the given function small a is msb, small b is lsb. So we'll connect msb to msb, a is connected to s1, b is connected to s0. Since there are only, there is only one output, right, because I am using only one 4:1 mux in the 74153. Right, so we'll directly connect as we discussed in the last 2 examples, like 3:8 in 8:1 mux. We directly connected data to, or grounded, or VCC to data lines. Like that we will connect those data lines to either VCC or ground, according to the given function. Right, so when select lines are, there are 2 select lines, so they can take 4 combinations. Right, so when they are 0 0, then d0 is selected. Do you have 0 in the given function? Yes, so that means d0 is needs to be connected to VCC. Do we have d1 and d2? No, so short them and connect them to ground. d3, yes I have, so I need to connect d3 to VCC. Right, so I'll check only for 2 combinations. When select lines are 0 0, it will select d0, and f1 will be equal to 1. Right, so and when select lines are 1 0, it will select D2 and which is connected to ground, so F1 is equal to 0, right? So we'll see some more examples in next class.